Hi everyone, this is Nicole Fry. I'm a risk assessor from the San Francisco Regional Water Board, and today I'll be going through a small dry cleaner case study. The source property is shown here. It currently contains a convenience store as well as a laundromat. The laundromat is the location of a former dry cleaning business where tetrachloroethylene, or PCE, was released. Subsurface staining in the building suggests that there was a release to the subsurface directly below the building's slab. We are concerned about vapor intrusion at both of these buildings. However, we also need to consider the surrounding area to ensure that we protect all nearby building occupants from vapor intrusion as well. Given the potential for direct exposure to current building occupants in this area, it is important to conduct public outreach. Public outreach should be conducted early and often throughout the vapor intrusion investigation. At the beginning of an investigation, a public participation plan should be developed as soon as possible. DTSC's Vapor Intrusion Public Participation Advisory provides in-depth guidance on developing a plan. Here I'm going to briefly highlight some of the major components that should be included in every public participation plan. The plan should include community information. This includes things like land use and languages used by the community. The plan should also include a mailing list of all stakeholders. A community interest evaluation survey should be included in the plan as well. This survey is sent out to stakeholders to get a sense of their level of interest in the case and to better understand what specific concerns they have. There should also be a plan for obtaining off-site property access. Historically, there has been a reluctance to do investigations that require sampling on private properties. However, given the new lower vapor intrusion screening levels, sampling on properties surrounding the released property will be necessary at most VI sites. There should also be a plan for communicating the results of any indoor air investigations. The community will be very interested in getting these results. Therefore, you should be prepared to explain the results in a way that everyone can understand and to put the VI risk into context for the building occupants. The communication methods and timing should be clearly described in the public participation plan. For example, will you be communicating using fact sheets, work notices, or community meetings? And will things be sent out via mail or email? For timing, it's particularly important to set clear expectations about when stakeholders will be getting information. Once an initial public participation plan has been drafted, it should be used throughout the vapor intrusion investigation and updated with new information as it becomes available. Now we are ready to begin screening buildings using the four-step process shown here. It is important to note that all buildings will not be on the same step at the same time as the site investigation progresses. You will see this as we go through the case study. The first step in the process, step 1A, helps us decide when to expedite VI evaluations. Immediate investigation or action should be taken if a fire or exposure hazard exists, or if acute or short-term exposures could result in adverse health effects. Neither of these are concerned for this site, so there is no need to expedite this investigation. Therefore, we will proceed as usual. Now we will decide which buildings should be screened first using step 1B. When prioritizing buildings, you should consider both the proximity of buildings to contamination and whether buildings are occupied or not. Let's first focus on proximity. Initial screening should include all buildings within 100 feet of a release area. The term release area has a specific meaning in the guidance document. It is defined as the area of suspected vadose-sown soil contamination extending out from a primary source. The red dashed line shows the suspected extent of the release area. It is initially estimated to be directly below the former dry cleaner building based on floor staining. We also want to include all buildings within 100 feet of groundwater contamination. Since we only have one initial groundwater sample, the 100-foot radius does not change in this scenario. Using this information, we can see that the highlighted buildings are all within 100 feet of known contamination. Now we will identify which buildings are currently occupied and screen those first. The 3 buildings to the south of the source property are unoccupied warehouses, so we can wait to screen those buildings. Instead, focus our initial investigation on screening the 4 occupied buildings to the north. Now we need to decide on a sampling approach. Step 1C explains how to decide if a building should be screened using soil gas sampling, as described in Step 2, or if you should skip directly to indoor air sampling, as described in Step 3. In order to decide on the correct sampling approach, we need to decide whether exterior soil gas sampling is likely to be representative of the VI risk for each building. To answer this question, we need to consider the lateral and vertical location of the release area with respect to a building. In the first diagram on the left, the release area is outside the building footprint here. Therefore, sampling at the exterior soil gas probe here should give good estimate of the VI risk. Conversely, looking at the diagram to the right, the release area is directly below the building here. In this scenario, samples from the exterior soil gas probe would underestimate the VI risk. Therefore, indoor air sampling is needed here. We also need to consider whether vapors could be transported through vapor conduits. In the diagram on the far right, a sewer line runs through the release area, and cracks in the pipes allow contaminant vapors to travel inside the sewer pipe towards the building. Since the sewer inlets at the building are not sealed properly, vapors are released into the indoor air. In this scenario, soil gas samples from the exterior soil gas probe will underestimate the VI risk, so we would need to do indoor air sampling. Now we are ready to apply these principles to our case study site. Okay, now let's locate contamination and transport pathways at the site so we can select the appropriate sampling approach. To do this, we will answer the following questions. Is the release area below buildings? Yes, you can see the release area is directly below the dry cleaner. Is groundwater less than or equal to 5 feet below ground surface? No. Groundwater is 25 feet below ground surface at the site. This is good because we want to be able to collect soil gas samples deeper than 5 feet to ensure that the samples are not diluted by ambient air, which could cause us to underestimate the VI risk. Is there a suspected discharge into the sewer? No, there's no evidence of discharge directly into the sewer for this site. This information will help us rule out the sewer as a vapor conduit. Do sewer pipes intersect the release area? Yes, the sewer lateral goes below the former dry cleaner through the release area. This suggests that the sewer could be a potential vapor conduit pathway. However, we also need to know if the sewer is cracked or offset near the release area to determine if the contamination can get into the sewer line. For this site, the answer is no, since the sewer lateral was recently replaced. So even though the sewer intersects the release area, the sewer does not appear to be a vapor conduit because contamination can't get into the sewer line. However, we also need to determine if sewer pipes intersect the groundwater plume. Again, the answer is no for this site, since the sewer pipes are in the vadose zone, less than 15 feet below ground surface, while groundwater is deeper at 25 feet. This helps confirm that the sewer is not a likely vapor conduit given the current site information. Now we can finally select the appropriate sampling approach for each of the 4 buildings we are initially screening for VI risk. At the former dry cleaner, exterior soil gas will not be representative of the VI risk since the release area is directly below the building. Therefore, we will skip directly to Step 3 and conduct an indoor air investigation at this building. However, exterior soil gas will be representative of the VI risk at the other 3 buildings, since there is sufficient distance between these buildings and the suspected soil and groundwater contamination, and no vapor conduits appear to connect these buildings to contamination. Therefore, we will use soil gas sampling, as described in Step 2, to screen these buildings for VI risk. The indoor air and soil gas investigations will be conducted concurrently. However, for clarity, I will be going through each one separately in part 2 of the case study.